homework number 8 was all about the second derivative test. Remember that the second derivative test, like the first derivative test, helps us find local extrema. So starting with problem number 3, we're given this function. Our first step is to find the derivative. So here's our power rule. And then we find all of our critical numbers. So we're going to set our derivative equal to 0. 12x cubed minus 12x squared equals 0. We can factor this. And we get x equals 0 and x equals 1. And both of those are our critical numbers. Now we find our second derivative. We use the power rule again. We're going to get 36x squared minus 24x. And we take our critical numbers, which were 0 and 1, and substitute them into our second derivative. So f double prime of 0 is 36 times 0 squared minus 24 times 0 turns out to be equal to 0, which means that for x equals 0, our test fails. So what we would have to do is go back and use the first derivative test to decide if there is a local max or min at x equals 0. But let's try f double prime of 1 is 36 times 1 squared minus 24 times 1. That looks like 36 minus 24, which is 12, which is a positive number. So we must have a local minimum at x equals 1. So all we have to do is write a statement. F of 1 is a local minimum since f double prime at 1 is positive. Okay, now we'll look at number 19. It's going to be the same process. We're looking for the local extrema, but just on the interval 0 to 2 pi. So we take our derivative. F prime will be negative sine plus cos. We look for our critical numbers. We set this equal to 0. So this would be wherever cos x is equal to sine x, and that's going to happen in two places. In the first quadrant at pi over 4, and in the third quadrant at 5 pi over 4. So now we get to find the second derivative. So our second derivative will be negative cos x minus sine x. And let's substitute our critical numbers. We'll start with pi over 4. And this turns out to be negative radical 2 over 2 minus radical 2 over 2, which is negative 2 radical 2 over 2, or negative radical 2. And negative radical 2 is less than 0. So we know we're dealing with a local maximum. So let's write our statement. F of pi over 4 is a local maximum since f double prime of pi over 4 is negative. So now let's try 5 pi over 4. Negative cos 5 pi over 4 minus sine of 5 pi over 4. That's going to be negative radical 2 over 2 minus negative radical 2 over 2. So both of these become positives. And radical 2 is a positive number. So now we're looking at a local minimum. So we write our statement. F of 5 pi over 4 is a local minimum since the second derivative is a positive number.